Okay. Okay, good morning, everyone. How did your homework go? Do you have questions about the homework? Okay, let's do it. Every time we start, you ask me questions about your homework. What did you do? What you able to get? What you didn't understand? Okay, so on the chat, I'll give you a minute to get your, homework together, and please put questions on chat. And every time, that's how we start. So please be ready to be able to do that. So, while waiting for you guys to put your questions, I'm going to comment about the quiz. Now, every time I grade a quiz, I give you feedback. It's crucial that you read the feedback, because if you don't read them, you don't understand your mistake, you will be repeating them. And I usually comment on the problem that there were issues with. So comment on the quiz. Right? The question that I felt that you had difficulties with was problem number 2. Okay, that was more common among students. So I gave you, I think number 3, I forgot the number. So I remember I gave you a circle and I gave you an angle T. I just picked it from here to here. So I picked the angle T in the first quadrant. And then I asked you questions. For each of the quantity below, decide whether it's a positive, negative, or 0. That's really my question. First, we can't answer this question unless we remember the definition of cosine and sine. It's crucial. So what's the cosine? So let us recall. Always. Okay, let us recall that. If this is a point P, the cosine of T is the x coordinate. Actually, let me call this in general, and then I'll go back to the problem. The cosine of theta is the x coordinate of the point P. It means whatever I have here, this is the cosine of theta, whatever the x coordinate is. And the sine is the y coordinate of the point P. And this is as long as I am on the unit circle. That's the correct. So this point, so this is that's the sine. So this is what you have to keep in your mind. There is no way out we can get through the course if this is not really clear. That's the definition. You don't have to, there's nothing to understand. That's the definition. So this point P is the cosine and the sine. Okay, so that's really the heart of it. Now I go back to your problem. And so from the quiz, I think it's number 2. Yeah, I think it's number 2. I don't know. So I had this circle. Okay. And instead of calling the angle theta, I called it T. Big deal. And then I ask you questions about that. What's the sign? It means positive, negative, or 0 of cosine T. Okay. To find the cosine T, I have to look at the angle T, and I take the point P. That's crucial. That's the point P. And the cosine is the x coordinate of the point P. So cosine T, so that's the x coordinate of the point P. But point P is in the first quadrant. It means its x coordinate is absolutely positive. P in quadrant 1. So the x coordinate is positive. Okay, so that's for the first question. Now, the second question. So that was A, if I remember. So A. My second question was, I think, sine of 180 plus t. Okay, and I can't answer this question till I see 180 plus t is where on my picture. If I go back here, what's 180 plus t? Means you take t, you add 180 degrees to it. You take t, you add 100 degrees. You take t, and you're going to add 100 degrees. It means basically you're going to end up, this is 100 180. So that's a t, whatever t is, you're adding 180 to it. So you're going to end up right here. I'm going to call this point Q. Okay, so what is the sine of 180? So if you want the sine of any angle, whatever this angle is, you have to draw the angle starting from the positive x-axis. You draw the angle and you look for, since I want the sine, you look for the y-coordinate. So sine of 180 plus t, this is my point Q. It's right there. That's the sine. So that's right here. Whatever this number is, that's the sine. So it's the y-coordinate of the point Q, the one I have right here. But Q is in the third quadrant. In third quadrant. So the sine of 180 plus t, because Q is in this quadrant, it means its y-coordinate is negative. That's negative. Okay? Very good. Now, the last one was C. And this was the cosine of 180 minus t. Okay? Now, what is 180 minus t? I'm going to draw the circle again. And this is where a lot of you messed up. Okay, so this is my center. That's my unit circle. That's my circle. Okay, what is 180 minus t? I'm going to ask you a question. Suppose this is an angle t. That's my t. I'm going to draw another one. Watch how I'm going to draw it. Basically, I'm going to take this angle here to be t. Okay, this is t. It means those two are equal. Those and those are the exact same thing. So if this is 30, it's a 30. If this is 40, this is 40. If this is 50, this is the exact same thing. And now my question to you, how much do we have from here to here? How much do we have from here to here? Back to you. Let's look at the picture. No more, no less. Okay, before I pick one, who wants to answer? Jaden, you want to?
Give me a second, Professor. Yes, I'll answer it. Give me 1 minute to figure it out.
Yeah, no problem. Just look at the picture. This is t here. This is t here. The same thing. In terms of t, what's this? Just look at the picture. I don't want more than that.
Is it 180 minus t? So
right, it's 180 minus t. Why it's 180 minus t? Just look. I mean, all of you. From here to here, it's 180. I'm taking t away from it. So this is 180 minus t. This is the point. A lot of you struggled with that. Okay, so from here, the positive x-axis. So basically, this is the angle t. You actually take the symmetric of it. When you take the symmetric of it with respect to the y-axis, this is t right there. So those two are equal to one another. So 180 minus t is from here all the way up to here. That's the 180 minus t. Okay. So I'm going to call this r, for example. So if I want the cosine, so this is 180 minus t, I want the x-coordinate of this point. So the cosine is the x-coordinate of the point r. This is the point r, right there. But r is in the second quadrant. So the cosine of it, it means that the x-coordinate of it is a negative number. So the cosine of 180 minus t is definitely a negative number because it's the x-coordinate. So in the picture, whatever this happened to be, that's the cosine of 180 minus t, whatever this number here. This is where your difficulty came. A lot of you could not locate 180 minus t. So this is your angle t. You want one angle, you take the symmetric, it means you take here, those two angles to be equal. What's left is 180, you take the t away. That's what's left right here, okay? Yes, when I ask you to explain, some of you just gave me positive, negative. I took points off, and I will always do that. And I wanted to explain, so that's how I expect you to explain. All right, so if I tell you explain clearly, I want an explanation because I want to know whether you get it or not. That's really what I want. All right, any other questions? Okay, so that was the question that is so crucial because it's of importance. I definitely want you all to understand. Okay, everything else, you struggled so-so, it wasn't bad, but that was really the problem that bothers me, and not bothers me, I want you to do it, okay? And any questions about that? Please go over it, you have to understand it. And you ask me. Okay, now we go through the questions that you guys having trouble with. So number 25. A. Okay. All right, I will do that, and I want to make sure you got other problems right. Okay. So before I go on, I would like to have a look at like 10 and 17. So I'm going to look at number 10 and 17. Okay. And then I will answer your question. So number 10 and 17. Let me remind you, always we recall till they become clear. The picture. If I am on the unit circle, if I am on the unit circle, and I know the angle, so I know that this is the point, let us say theta, I know what the angle is, then the point P, I can use my calculator to find the X and Y coordinate. So if I know the angle, I can use that to find the Y and coordinate. So the point P has for coordinate cosine theta, sine theta. Okay, so that's the point. That's the definition. So if I know the angle, I can find the X and Y coordinate as long as it's a unit circle. However, if I am on a circle of radius R, so it's not the unit anymore. This is a point R. That's R here. So circle of radius R. If I know the angle, theta, okay, I can use my calculator to find the coordinate of this point. And what are the coordinates? Who can remind me quickly? What happened when the circle became of radius R? What happened to the coordinate? Speak up, please.
You multiply the sine and cosine of theta by the radius.
Right.
Because,
Go ahead.
No, I was just going to say that it's because it's assumed on a unit circle that the radius is 1. So when the radius becomes more, you multiply it by the radius.
Because we stretch by the same amount. I mean, we're basically stretching everything. So that's R cosine theta, R sine theta. This is R sine theta on my picture. This is R cosine theta. Okay. That's, again, very important for us. That's why I'm emphasizing it. So I will do 2 problems. I'll do number 10 and number 17. Okay. Number 10, they tell me you have a circle. You have a circle. And the radius of the circle is 3.8. So that's verbatim from your book. So that's the radius. And find the coordinate of the point at the given angle on the circle of radius 3.8. So number 10, so this is 3.8. Angle is 180. And they want me to find the coordinate of the point, which is determined by this angle. It means you take 180. That's a very simple one. You take the point on the circle of radius 3.8. You get this point P. And they want me to find the coordinate. Okay, now without any math or anything, what are the coordinates of the point P? Quickly. You want me to pick one, or someone of you want to?
Would it be -1, 0?
No.
There's a
Why?
negative 3.80.
Right. What's the radius here? I want you to
okay.
be careful with the radius. I want you to be very careful with the radius. The radius is 3.8. So this is going to be, sorry, I'm going to write it bigger, minus 3.8 and 0. That's really why I'm emphasizing. When you change, you make the circle bigger, you multiply by the radius, basically. So it was -1, but you have to multiply by the radius. It's going to give you minus 3.8. So minus 3.80. All right. So that was a simple one, but to get the picture, it's not -1, because that's my radius now. Very good. Now, number 17, I think, whatever. I mean, any one is the same. It's the same question. So the radius is 3.8, but the angle is -10. Okay. Sorry. The angle is -10. All right. First, I draw. So remember again, that's not the unit circle in this particular problem. So the coordinate will change. So here, that's basically 3.8 -10. -10 means you have to go down. It's we go down a little bit. It's really -10 degrees. So this is -10. And the question is to find the coordinate of this point right there. Okay, so it means I need to find the x, sorry, the y, and the x coordinate. That's really what I need to find. Okay. All right, I did 10, I guess. Oh, I'm sorry, I did 11. Thank you for correcting me. And now I'm doing 17. Very good. Now, what's the coordinate of the point P? Now we know from the picture, the y has to be negative and the x has to be positive. At least we know that much. But now exactly how much, that's where we're gonna use our calculator for that. Okay, so what's the x coordinate? What's the y coordinate? And then we put them here. Okay, the x coordinate is what? Quickly, the formula. Did you guys memorize it? It's the radius times the cosine of the angle, whatever the angle is. The y is the radius times the sine of the angle, whatever the angle is. Okay, so r times the cosine, r times the sine. Now the rest is picking up our calculator and really compute them. That's what's left. So for the x coordinate, I get 3.8. You guys see the calc? I know it's not very clear, but kind of cosine of -10. And I have a syntax error, sorry. So at 3.8 times cosine of -10, and I'm getting 3.742. 3.742. Anybody got anything close to me? I do a lot of stupid mistakes, so you correct me. Which is makes sense. If you look at the picture, this is 3.8. -10 is really, really very tiny. So the cosine, which is this x coordinate, is going to be close to 3.8. Because -10, actually, if you want to be very accurate, but I will have a bad picture, it's very, very close to 0. So the answer is 3.7, which actually makes sense because 10 is very little. So this is 0.742. Now the sine. How much did you guys get for the sine? So I'll do it and you do it. And let's see what we got. How much did you guys get? Okay, so if we round it, minus 0.65. Okay, you can round it minus 0.66. So it means this point, no, sorry. Yeah, this point is minus 0.66. Okay, so the point P has for coordinate 3.742 minus, we expected a minus 0.66. End of the problem. Okay. Oh. Now I know that 24, I think your question is, right, at the beginning. Let me pull it up. Okay, 25. Okay, 25. Before I do 25, because I want to make sure you got, I will do 24 and then finally I will do 25. Okay, and then I move on. So 24, the question is, and this is your homework, so I expect you guys to be able to answer me. So the question is, find an angle. Find angle between 0 and 60. Sorry, 0 and 360. But not 240. They don't want 240. That have the same cosine, have same A cosine as 240. Okay, so want an angle between 0 and 360 that have the same as cosine as 240. So I draw my unit circle. That's my unit circle. And that's my unit circle. 240. So 240 is, what is it, 240? This is 180. So 240 minus 180, that's 60. So I know exactly what it is. So it means you have 60 degrees here. So that should be 240. Okay, and the cosine, that's the cosine, whatever this number. Now I am on the unit circle because I'm talking. Okay, so I want you to tell me, where can I find the angle that have the same cosine as cosine 240? Anybody? I mean, how did you guys do that? Please put your camera on. Reflected across the x-axis. So is he correct? Because the only point, so I want this point, total reflection across the x-axis. And I want this angle. Because if I take the point Q, so that's the angle I want. Because if I look at the picture very, very carefully, point Q and point P have the same x coordinate. So if I know what this angle is, the one in red, the cosine of this angle, which is the x coordinate of the point Q, will be the same as the cosine of the angle 240, which is the x coordinate of P. So now what I'm left with is, what's this angle in red? It's equal to what?
120.
What?
I believe it's 120.
You believe it's 120? You know what? Tell me how.
I subtracted 180 minus 60.
Yes, absolutely correct. Where is your 60 from? You're correct. Just tell me.
It was the distance from after the 180 point to the point P.
Exactly. That's what you go to. Always go for the acute angle between your x-axis and the terminal side of your angle OP. This is usually your guideline. If you know this, the picture will be clear. So this angle here is basically 60. Okay, so if you can write it if you want, usually find, that's always helpful, find the acute angle. Acute, it means less than 90, between acute angle between the terminal side of 240 and the x-axis. And next time we're gonna give this angle a name and we're gonna call it reference angle. But this time, that's really this angle. If you know this angle, you know everything. By symmetry, this angle right here will be 60. So the angle I'm looking for is 180, you take 60 away. which is 120. That's really the picture. So the other angle is, the angle I'm looking for is 120. So once you draw the picture, things will become actually clear. Okay, B, the sine. I want an angle that have the same sine as 240. I think, yeah. Okay. Again, I have to give you a minute to think about it, and then, I mean, you should have done it, and then you answered me. So first you start with your unit circle, always unit circle. You draw the line 240 that we located, we know exactly what it is, and we know this one. Always this angle will be very important for us. Okay. Now I want you guys to give me the angle I'm looking for. Remember, I want it to have the same sign. Okay, I'm getting answers. Anybody else? I'm going, okay, student are telling me reflect over the y-axis. Reflect over the y-axis. That's the y. That's the point Q. So if I take the angle from here, this red angle, if I call the theta, then the sine of theta is the same as the sine of 240. The sine of 240. So this is 240. The sine of 240 is the y-coordinate of P. The sine of theta is the y-coordinate of Q. Since they are symmetric, they have the same line. So now what is theta? Theta is 360. Because if this is also 60. Minus the 60, which is the 300. Okay. All right, now we finish with number 25. Please ask questions, because you're going to be tested on this stuff. I really want you to get it. Good. So let me do 25. Do 25. You have a point P on the unit circle. That's my unit circle, kind of. That's one, crucial. And that's my unit circle. And I have a point P. So I have a point P. And the point P has for coordinate 0.701. That's the coordinate. 701. So the x and y coordinate are equal to each other. So given the point P with this coordinate is a point on the unit circle with angle 45. It means it's halfway, right there, right in the middle. This is 45 degrees. And this point here is my P, 0.707, 0.707. Okay. The question is, estimate, because I want us to estimate sine of 135 and the cosine of 135. Of course, they have to be a relationship. Okay, that's the problem. Ideas. The only hint I give you, what is 135? What's the relationship between 135 and 45? And then the rest, I hope, will be easy.
If you multiply 45 times 3, it'll equal 135.
That's one idea. But what is it exactly on the unit circle, though?
Both of them add up to be 180 degrees.
Right, both of them add up to be 180 degrees. Very good. So where is my angle 135 on the unit circle? So everything you said is correct. I still want to see it on the unit circle. Where is it with respect to the point P? So once one of you told me something, it's 45 plus 135 is 180. Absolutely correct. You just add them. So 135 is how much? Is 180 minus 45. Why did I say that? What's the importance of it? No, over. You have to be clear. Is it the x or the y-axis? So it's 180 minus 45. What is 180 minus 45? Means I take exactly 145 here. That's 45. This is 180 minus 45. That's exactly it. Minus 45. That's what it is. So the point, so if I look at the point Q here, the angle that between OQ and the positive x-axis, this is 135. Look at the picture very carefully. Okay, so this is 135 degrees. It's the point which is symmetric to the point P with respect to the y-axis. So now if I need the sine and the cosine, so the sine is the x-coordinate. No, sorry, nonsense. Since I wrote nonsense, I rewrite. So the sine is the y-coordinate of the point Q, and the cosine is the x-coordinate. Equal. So what's the y-coordinate of Q and what's the x-coordinate of Q? Use the picture verbatim. Okay, do you want me to pick one of you to be mean? Caleb Johnson, do you have any idea? Are you with me? Okay, I'll pick another one. Samantha, are you with me?
Yeah.
Okay, can you tell me the answer? Give it your best shot. Use the picture.
This is like the stuff I didn't understand, so I was just writing it down and trying to get a grasp of it.
That's okay. That's all right. Take your time. It's fine. Do you see 135?
Yeah.
Do you understand why it's 135?
Yeah.
Kind of. Because what's the angle here?
Because the angle is 45 right there. So 180 minus 45 is 135.
Exactly. Now, so that's the angle. What's the sine of the angle? That's our definition. The sine is the y-coordinate. So cosine is the x-coordinate. That's the definition. That's the definition, pure and simple. In this picture, what's the y-coordinate of Q? Look very carefully at the picture. You have P. So it means that this point here, if the point P has for coordinate 0.7, means this point is the y-coordinate of Q. It's the same as the y-coordinate of P. Means it has to be 0.707. Total symmetry. We're going to work a lot with the symmetry of the unit circle. Okay, can you give the x-coordinate your best answer?
I'm not really sure.
Okay, what's this point here? What's this x-coordinate? This 0.707.
Yeah.
This is 0.707. I'm looking at the one here, totally symmetric to it.
So wouldn't it be negative 0.707?
Don't be afraid, negative 0.707. That's the picture. So that's going to be minus 0.707. Okay, so you draw the angle. And we're going to use always the symmetry of the unit circle. And we're going to use it a lot. It's crucial for us. That's why I'm going over it. So that's the point P here. So the cosine of 45 is the x-coordinate The sine is the y-coordinate. Now I want 135. So I draw the 135 and I can't find the relationship between 135 and 45, the geometric relationship. So in terms of geometric relationship, this is 45 here. That's my angle, 135. If I want the cosine, it means I want the coordinate of that point. Now I know that. So by symmetry, Q and P have the same y-coordinate. That's why it is, the sine is 0.707. However, the x-coordinate, if this is 0.707, this is going to be minus 0.707. So the cosine here is going to be a negative number because it's the x-coordinate of that point. Okay. All right, so this is part A. So for next time, because I don't want to be the one doing it, I'm going to assign 25B. And I want you to do it and see how well you can do with that. So I did A, I want to assign B for next time. I don't want to do it myself. And I will see how you guys did with that, okay? All right. Okay, today we're gonna start the following section. I mean, it's not, actually it also solidify our understanding more and more. And 7.3.
I had a question, if you don't
Of
mind.
course. No, go ahead.
I was just wondering because I didn't understand quite what 29 and 30 was asking for.
29 and 30.
The problems didn't seem hard, but I just didn't know what it wanted the answer to be, whether it be the quadrant or
Yeah.
Positive,
It's just,
negative.
yeah. It's in terms of A, they want the answer.
right.
Okay, so if I look at 29 here. Let theta be the angle in the first quadrant with sine theta equal A.
Right.
So I will draw it. Okay, theta is in the first quadrant, somewhere here. Okay, and the sine is A. What is the sine?
The sine is the y-coordinate.
Is the y-coordinate. With me?
Yes.
Now, evaluate the following in terms of A. Sine theta plus 360. If they want me to find the sine of theta plus 360, I have to draw this angle. Okay, what theta plus 360? I want
It would
What?
overlap. It would
Exactly.
overlap.
So the point on the unit circle that correspond to this angle is the point P itself. You understand? Sorry, do you guys follow me?
I'm following.
Anybody else? So theta, it means theta. You add a full circle, it means you're back to the point P itself. So the sine of it is exactly the sine of the point P because it's the same point. So this is going to be equal to A. That's my unit circle.
Right.
Now, I will pick another one. Suppose I take sine of theta plus 180. Again, the only way you can answer the question is to go to your circle and ask yourself, where is theta plus 180 on the unit circle?
It's in the third quadrant.
Right, if this is theta, you're gonna add 180 degrees. So it's gonna go from here all the way to here. That's 180 plus theta. What's the sine of it? It's the y, let me call it Q. So the sine is the y coordinate of Q. What's the y coordinate of Q in terms of A?
It's negative A.
Negative A. Total symmetry. We're using symmetry over and over and over. So if this is A, this is minus.
So for the entirety of 29, you're just determining whether the y value A is negative or positive?
Right. We're determining that.
Okay, that's That's all I was unclear of. I didn't
Yes,
know
yes.
what they were exactly asking for.
Don't worry about C for now. So if you guys doing it, I don't want you to care about C. I don't want you to worry about F. Do the rest. Okay? Do the rest. And you will be fine. For 30 is exactly the same thing. I don't want you to worry about C and F. Everything else you should be able to do it. No question asked. And check your answer. All right? Make sense now? All right. So okay, so section 7.3, as I said, I hope this isn't going to be hard, is unit of measurement. So far, we've used degree as a unit of measurement for the angle. So we measure it in degree. But there is another unit of measurement. It's called radian. So radian and arc length, whatever. We'll talk about that later. Okay. I mean, as you know, if you take length, there are 2 units of measurement. Now, a lot of units, but 1 unit of measurement is the inch. And then you have the unit that everybody else in the world use, except in this country, which is the inch, which is the centimeter, right? So there are 2 units of measurement for that, all right? For angles, also we have 2 units of measurement. The degree is just the following idea. It's just taking this here and dividing it in 360 pieces. That's really what a degree is. 360, and this little bit here is the 1 degree. So it's a really, really tiny number. Where the 360 comes from, ask the Babylonian, you know, thousands of years before Christ. So they decided 360 and we went along with it. But now we are so used to it, so we actually kind of understand it well. But there is another unit, which is the radian. I'm sure some of you have heard of it, which is actually the more interesting one. And that's the one that actually calculus and everything uses. So once you hit calculus, the degree will disappear. Radian will be the unit that you will use. But what is a radian first? So radian measure. So it's a unit of measurement, the way we measure angle. Radian measure. First, what is a radian? A degree is what I told you. You take this and you divide this one into 360, and the degree is this tiny bit here. Okay, now what is the radian? The radian is actually a more interesting measure. It's obtained like this. First, what is 1 radian? Is what? 1 radian. It's a unit that usually we denote it by RD for radian. Okay, so what it is? It's the following. That's how much is 1 radian. Again, go back to our unit circle. That's my unit circle. And we do the following. You can start any point on the unit circle. It doesn't really matter. Suppose I start here. So that's a unit circle, unit circle. And you start here and you take an arc, length of the arc. So imagine yourself that you move along those arc and you move 1 unit along the arc. So you move 1 unit. So that's an arc. And from here to here, the length is 1. It means if you take this little piece, you stretch it, you get the same length as the radius. So from here to here, length of this arc is 1. The angle at the center, this angle here, at the center, this is the 1 radian. So 1 radian is big. It's not like the degree, it's just tiny, 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 tiny. The radian is really 1 big. So what's 1 radian? So 1 radian is actually the following. Is the angle at the center of a unit circle and the book call it which span an arc of 1. I hate the language, but an arc of length 1. Okay, what I mean by span an arc of length 1, it means exact, means the arc that determined by this angle. It means this arc, that's what they mean, the arc that this angle span is of length 1. So that's really the radian. It has a very, very specific geometric meaning. That's why it's used later on. As I said, once you hit calculus, degree will disappear, radian will take over. Now, so how much is half a radian? So how much is half a radian? So by analogy, if I want to tell you, so that's 1 radian, that's the important one. So half, not the important, but that's, how much is half a radian? Half a radian, this is a radian. Half a radian, it means you take an arc of length a half. So length is a half. And the angle in between, that's half a radian. Okay, length half. What's 2 radian? Simple as that. So that's half a radian. Now, how much is 2 radian? Again, you take the unit circle. And 2 radian, it means you need to span an arc of length 2. Now, suppose I start here. So this is from here to here, that's 1. And you're walking. You imagine yourself walking along 1 unit, 2 unit. So the length from here to here is also 1. So that's 2 radian. That's what the unit radian means. 3 radian, you move a little bit more. 4 radian, you have to move, and so on and so forth. So now the first question, of course, we're going to answer ourselves is, how many radian are in a full circle? It means from here to here. How many radian do we have? Okay, so what's going on here? And how can I find those answers? Okay, so how many radian correspond to the 360 degrees, basically? Okay, I'm going to take again the unit circle. Okay, the unit circle. I'm going to find out how many radian we have. All right. First, I need the following thing. What's the that's a unit circle. I need this, that's the following thing I need. The circumference, or the perimeter of the circle. You guys remember the formula for the perimeter of a circle? Anybody? Anybody remember the circumference of a circle?
Is it C equals pi times the diameter?
Yeah. So circumference of a unit circle. Sorry, in this case. It's pi times the diameter or 2 pi times the radius. Either one is correct. Okay, it's the same thing because the diameter is twice the radius. So it's 2 pi times the radius. Since I am working with the unit circle, the radius is 1. So it's 2 pi. That's the 2 pi unit. So if your unit is centimeter, it means 2 pi centimeter. But what's 2 pi? 2 pi, I agree. But what is pi? Do you know how much pi is? You know how much pi is? Almost.
It's 3.14 or 180 degrees.
Yeah, let's assume 3.14. I don't want to push it hard more than that. So 2 pi, it means I multiply this by 2, 6.28. Roughly, because it's actually, we have a better approximation. Okay, so what does this mean? It means that if the length of that, if I go around it, it's 6.28 unit, whatever your unit is. Meter is 6.28 meter, if that's the radius. Inches, 6.28 inches, whatever the unit is. So that's the circumference. And now my question is, how many radian can I fit in this circle? So we know the length. The length is, of this whole thing, is 6.28 unit, almost, because I am approximating pi quite a bit. Okay, so let's see how many radian can we fit. The whole thing is 6.28. So how many radian can I fit? 1, 2 radian, not 6. So at this point, the length of the top half is 3.14. So 3 radian, this is a little bit, 0.14, 4 radian, probably this is gonna somewhere here. 5 radian, 6 radian, but there will be a little bit of leftover. Okay, because the length is 6.28. So this piece here, there's still left. So I have 1 radian, 2 2 radian, 3 radian, 4 radian, 5 radian, 6 radian. 1, 2, 3, 4, 5, 6. And here I have the length here is 0.28 unit. That's the length here. It means here I have 0.28 radian. Because the amount of radian I have is exactly the length of my unit circle. So if I have half a radian, that's half. 1/4 of a radian, that's 1/4. So how much do I have from here to here? 1, 2, 3, 4, 5, 6, and 28 radian. So the 360 degrees correspond basically to 6.28 radian. That's really where this whole thing is really coming from. Now, of course, 6.28, we're not going to keep it 6.28 because we need the exact value, which is going to be the 2 pi. So 360 degrees correspond to 2 pi radian. But I don't want the pi to be an abstract idea. Pi is almost 3.14. So when you say 2 pi, it means you're talking about 6.28 radian. So that's how many radian we have inside the circle. That's really my unit that we have to work with. Okay, crucial. So the radian is big. The radian is big. It's the degree which is very, very tiny. And you're going to figure out how much is a radian in degree. But before I do that, I want to build like a picture of, in one picture in your mind. So 360 degrees correspond to 2 pi radian. So the first important relationship between degree and radian. So the first important relationship between them is crucial. Okay, the first important relationship, and that's 360 degrees correspond to 2 pi radian, which is almost, I'll put that on purpose because I want you to understand that this is 6.28 radian. I really want you to understand that that's what it is. So 180 degrees, I like the 180 because it's how many radian? Quickly. 360 is 2 pi, 180 is half of it. So half of it is
Pi.
Pi radian. It means almost 3.14 radian. So that's what give you an idea. So 180 degrees, a little bit more than 3 radian. It's 3 radian and 0.14 of a radian. So that's how many we have. 1, 2 radian, 3 radian, and a little bit. And this is 0.14 radian. Okay. Before we start converting, before radian and degrees, we are going to talk a little bit about common angles. And after I do common angles, I will go back and start converting. But first, the common angles. We are before any conversion. So what do I mean by the common angle? Okay. So on the unit circle below, we're going to label the indicated common angles. Forget about label the common angle with their degrees and radian measure. All right, that's really the idea. So what do I mean by common angle? The common angles are the following angles, basically, in degrees first, and then we convert them to radian. The 30 degrees, 60 degrees, 90 degrees, 45 degrees, and so on and so forth. Those are what we mean by the common angle. And let us put them on the unit circle. First, you put them. So how does it work? That's my unit circle. That's a 0. So this is the angle, 0 degree. This is the 90 degrees. This is the 180 degrees. And that's the, how much this will be. How much this would be, quickly. That's a 0. That's 90 degrees. 180, how much this would be, you guys know? 170 degrees. All right. Now the other angle. I'm still in degrees, and then we're going to move them all to radian. Another angle. So as you can see in the picture, I divide this into 3 pieces. So it means that this is 90 divided by 3, so this is the 30-degree angle. We have to have the whole total picture of that. That's the 60-degree angle. And then I'm dividing into 3, so that's 30, 30, 30. And how much is that one? So I'm emphasizing the common angle now. How much is this one? Quickly. 120, because it's 1, 2, 3, 4 30s. 4 30s give me 120. And then this one is 530. This gives me 150. Okay, and I'm not going to do the rest, and I'm going to keep it for you. And now I'm going to emphasize on the top ones, and then I'll worry about the bottom one. Now I'm going to, the angle, which is in degrees, we're going to put it in radian. Okay, we're going to see the conversion of the most common angle, and this is, we have to absolutely memorize. So we're going to make a table down here, and then I rewrite it here. The angle in degrees, the common angle, of course, and angle in radian. Okay, so the common angle are going to be the 0, the 30. I'm going to put something here, which some of you know, 90, and then 120 is actually, we can figure it out once we know the first ones. And then I'm going to keep here 150, 180, and I'm going to put 270 here and 360. They're really the most common one. And this is in degree, and then it's in radian. All right. So 0 degrees is, of course, 0 radian. There is nothing here. Now 30 degrees. How much in radian? Now, for me, you know what? I only memorize one thing if you want. And then everything, so 180 degrees is pi radian,
Right.
3.14. So what's 30 degrees? So,
1/6 pi.
yeah, because 30 in 180, 30 is, there are 630 in 180. Am I right? Once you can see this idea, and then you're done. So 160 is pi, so it is 1/6 pi. It means it's pi over 6. Okay, that's 180, that's pi, and 30 is 1/6 of it. So each one of them is pi over 6. So that's pi over 6 radian. So the 30 degrees is pi over 6. Okay. Now, I guess 60 degrees. Okay, you have 2 ways to do it. You want to tell me 60, not by memory, but how can you figure it out?
You can double 30, or you can go by memory for 1/3 pi or pi over 3.
Yeah, you can double 30. So it's 2 times 30 if you want. It means 2 times pi over 6, which is eventually you have to memorize. 2 times pi over 6 is pi over 3. Or you can say it is 1/3 of 180. Because how many 60s in 180? In 180, you have 3 60s. It means pi over 3. So the 60 degrees is the pi over 3. Okay, and you have definitely have to memorize them. I mean, some of you have them memorized, some of you don't. Now 90 degrees.
One half pi or pi over 2.
Right, it's a half of 180. Okay, so 180 is the pi, 90 is half of it. So it's half of pi. So that's the pi over 2. Okay. Total memory, period. I mean, there is nothing. You don't have anything, but this is total memory. Okay, I will fill this out in a second. Okay, now 120. How much in radian? And now I'm going to ask one of you. So I'll give you a minute to figure it out quickly. This I'm going to pick. I want you to think about it and tell me the relationship. I mean, if you forgot what's 120 and you basically have those, how can you get 120 immediately? Because those are the one I want you to memorize. Everything else you can figure out. Ready? Okay, let me be mean. You know, I pick you arbitrarily. I really don't know you. So Phoenix, are you with me? Yes? Okay, can you figure out 120 in radian? You have this picture. Can you relate 120 to any of these angles? So you figure it out in radian. 2 pi over 3, because 120 is what? So if you want, 120 is 2/60. 2 times pi over 3. Anywhere you want. So that's 2 pi over 3. 150. Again, I'll give you a minute and I will pick another student. Okay. As I said, I honestly pick you arbitrarily. I don't. Maddie? Maddie, are you with me?
5 pi over 6.
Because you're right. Tell me, how did you, what is it you used?
I was just counting the angles every
That's-
third until I got
Okay, very good. She was counting the angle. So if she counted, it means you counted how many 30s, right?
5, yeah.
5 30s. Once you have that, you have the picture. 5 pi over 6. Okay. All right, 180. That shouldn't, that's pi. Okay, I fill that out. 270. This should be easy, so I'll pick quickly. Tim Da Silva. Are you with me? Are you with me, Tim? Yes, okay. What is 270 in radian? Look at your picture and tell me, connect dots. 270 is here, right there. So how many radian we have? Oh, 270. If you look at the pictures, how many 90s? 1, 2, 3 90s.
So would it be 3 pi over 2?
It's 3 pi over 2. Absolutely correct.
Okay.
Okay, it's 3 90s. Three pi over 2. All right. 360. Tim, can you stay with me?
Yeah.
360.
That's 2 pi.
That's
right?
the 2 pi.
Yeah.
Absolutely. Now there are still two that I want. The other angles, which are very important also, is the angle which is just go straight in the middle here. Okay. And that's the 45 degree, sorry, 45 degree angle. So 45 degree angle. How much this is in radian?
Pi over 4, right?
Yes, because it is what? It's half of whatever.
90. Yeah.
Half of pi over 2.
Right, which is 90. So
Yeah, which is pi over 2.
Again, yeah.
Okay, so, and actually I've left one here, so 135. I mean, you don't have to memorize 135. As I said, these are the ones that I want you to memorize. Those, you get them once you know this, you know everything. 135. Anybody can locate 135 in the picture. We just did 135, but I want to make it clear. 135 is How can you relate it to 45? How many of them? Anybody? How many 45 in is there in 135? It's 3 of them.
3.
3. So 135 is right there. That's my 135. So it's a 3 pi over 4. 45, that's the 3 pi over 4. So my theta here, that's 135. That's the 3 pi over 4. Okay, so these are the most common angle that we should definitely, absolutely be fairly comfortable with them. Now the downside, I'm gonna give you this problem and I'm gonna ask you for next time basically to fill the downside, which is not very hard. Okay, so these are the common angles. Now the question is, if let us say you have 50 degrees, and how many radian is 50 degrees? Now, of course, 50 is none of those really common angles. So I cannot use the logic that I'm going to use here. I mean, this logic really pertains to those common angles. So how are we going to make the conversion for any angle from degree to radian and from radian to degree? So conversion. Can I move on? Okay. So conversion between degree and radian. And that's not hard now. Degrees and radian. Okay, so let's see the main relationship between the degree and radian. The main relationship is 180 degrees is pi radian, almost 3.14 radian. I keep writing this just to remind you that pi is just this number, and that's an approximate number. So the question is, how much is 1 degree? So 180 of them is pi. So 1 degree is pi over 180 radian. So it's very small, a degree with respect to a radian. So 1 degree is pi over 180 radian, which is almost equal to, I will pick up, it's very, very tiny, the degree. So how many radians? So it's pi divided by 180. That's going to give me what I'm getting is almost 0.01745 radian. So a degree is really tiny. It's that many radian, very little radian. Now, again, I'm going to use the same relationship. How much is a radian to the degree? 3.14 radian or pi radian is 180 degrees. So one of them, basically you're asking how many pi's is there? It's 180 over pi. That's a radian, which is almost equal. And that's a good number that you should know because it helps you. So it's 180 divided by pi, it's 57.29 degree almost. Very important for you to know that. So how much is a radian? So to give you an idea, so in my unit circle, the radian, as I said, that's the unit circle. You start from here and you go a length of 1. So this is the radian here. It's almost 57 degrees. So this gives you a relationship, tells you how big is the radian as compared to the degree. So if 1 radian, you can fit 57 degrees. So it's quite a bit of radian in a degree. So it's important for us to see the relationship. Okay. Now we're going to do some conversion. So my question is, convert for example, 3 radian to degrees. Okay. Now, how is the conversion? All right, once we basically see this picture, then conversion becomes easy. One radian is 180 over pi. So that's one radian. That's what we know. Is 180 degrees over pi. So this is going to give me that 3 radian is 3 times that much. So you multiply by 180 over pi. That will give you 3 radian. 1 radian is 180 over pi. 3 of them is 3 times 180 over pi. So, and then we can, of course, we can pull the calculator and do that. So it's 3 times 180 over pi, which is I'm getting, okay, 3 radian. Do you think it's more than 180 or less than 180? 3 radian, less than 180 or more than 180? Absolutely less, because 180 is 3.14 radian. So if I need 3 radian, it's definitely going to be less than that. So, and according to here, I'm getting 171.88 degrees. That makes a lot of sense. It should be less than 180. Okay. So one more, I guess. No. Now I'm going to do the opposite. Convert, I don't know, 5 degrees to radian. Okay. You think I'm going to get a small number or a large number? 5 degrees to radian. You can round small, very, very small, because a degree is very small with respect to a radian. So 5 degrees is going to be really tiny. So, but let's see how to do the conversion. 1 degree is pi over 180. So if I need 5 of them, I have to multiply by that. Okay, it's a very, very tiny number. So this is going to give me, again, I'll use my calculator, 5 times pi divided by 180.
You flip-flopped it. 180 over pi.
You know, how would I know that I have a really wrong answer?
Because it wouldn't
Right.
have. Go ahead. Sorry.
No, I didn't flip it. 1 degree is how much? It's pi over 180. Right? Because 180 degrees is pi. So
My fault.
Yeah, but that's okay.
I
do a lot of stupid mistakes. That's why I trust you guys. So 5 times pi over 180, and I'm getting, which is we expected a small number, 87. And if I round to the 3rd decimal, that many radian. It has to be a small number because 5 degree is very small with respect to a radian. Okay, so to convert from radian to degree, so you basically say, okay, I mean, either way I memorize this, I only do that. I say pi radian is 180. That's really usually my guideline. I say, okay, pi radian, 3.14 radian is 180. Each one of them is 180 over pi. So 3 of them you multiply by 180 over pi. Convert from 5 degree to radian. I also go from here to here. Say pi radian is 180. Means every degree is pi divided by 180. How many 180 is there in pi? 5, you multiply by that. End of the conversion. Now sometimes I will ask you to convert, but I will tell you, okay, convert, but keep pi in the answer. So what do I mean by that? So suppose I tell you the following. Convert, let us say 25 degrees to radian and keep pi in the answer. Basically, I want pi in the answer. Okay, so this is degree and this is, I want it in radian. So I will say, okay, again, 1 degree is pi over 180. means 25 degrees. I multiply 25 times pi over 180. Okay, and I want you to keep pi, so I don't want to read the answer. So this will be the same as, the only you can do it is the same as 25 over 180 pi. Okay, I'm just using the property of fraction. Those two are exactly the same fraction. And now you can like simplify a little bit. A common factor is 5 and 5, because 25 is 5 times 5. And 180 is how much? 5 times what?
36.
36. So 5 is a common factor for denominator and denominator. So if you want to put it in its lowest term, this will become 5 over 36. So if I ask you to keep pi, that's the answer I am asking you to do. Otherwise, you can give me the answer rounded to 2 or 3 decimal places, whichever I ask you. Okay. So that's how we go from radian to degree. Radian, as I said, is a very important unit of measurement. In this course, we'll be working with both of them. And next time, we'll see how to use our calculator to be in radian mode or in degree mode. Okay, I think I have to stop here. For next time, please make sure you do the homework I assign. I'm going to assign something from 7.2. And definitely I will assign stuff from this section. And the other thing I probably will give you, I'm going to give you a picture of this circle, and I'm going you to practice writing on each one of them what's the angle, including the bottom one. And I will check with you next time. Okay, so I'm going to put this on as a worksheet and on your homework, and I want you to do that. Okay, so you become very, very comfortable with these ideas. Okay, any questions before I let you go? It's your chance. Any question?